So the equations or problems that we're going to see for this are really going to be straightforward. For example, we have a mountain climber. The mass of our mountain climber is 90 kilograms. The rope our mountain climber is using has an original length of 50 meters. Nice and long. The diameter of our rope is 10 millimeters. When the climber is simply hanging from the rope, the rope's going to be longer than 50 meters. The rope stretches, elongates as the person hangs from it. This particular rope elongates by 1.6 meters when this person just is hanging. So if the person's just hanging from the rope is 1.6 meters longer than it was before. What is Young's modulus for this specific rope? Young's modulus, the force. What force is being applied to the rope? mg. The area, that's the cross-sectional area of the rope. If you were to take the end of the rope and look at it, you'd see a little circle. Area of a circle is pi r squared. R is half the diameter. So that's our stress. The strain is the change in length over the original length. We know both of those values. So M is 90 kilograms. G is 9.8 meters per second squared. Pi, half the diameter is 5 millimeters. So 5 times 10 to the negative 3 meters. Delta L is 1.6 meters. L naught, the original length, is 50 meters. Plugging and chugging all of that through. .5 times 10 to the 8th. Units are newtons per meter squared. These meters cancel. Kilogram meter per second squared is a newton over meter squared. So our units are newtons per meter squared. You can work backwards. Also, say you know what the Young's modulus is, you can predict how much your object is going to stretch by or compress by. You can figure out what delta L will be for that particular object. So just basic equations is all we're going to look at. If I remember correctly, you have a problem on your homework that deals with the bulk modulus, where it tells you that the volume changes by a certain percent. I'll make up a value. I don't know what it says. So let's say the volume changes by 1%. What that means the final volume is if it's decreasing in volume, the final volume will be 0.99 times whatever the original volume was. Right with that? If the volume changes by 1%, then the volume that you have left is 99% of what it originally was. V initial is V naught. So delta V, V naught minus 0.99 V naught, 0.01 V naught. So we get 0.01 V naught over V naught. That is the strain. Whatever percentage it changes by is the strain. Now you have to write it as 0.01 as the decimal place, but whatever percent changes is your strain itself. So the delta V over V naught is the point 0, 1 that it changed by. Then you can relate it to pressures, knowing the bulk modulus.